Access control list. One of the best features about a Cisco router is its ability to filter traffic from one portion of a network to another. The tool that it'll use to do this is called an access control list, sometimes called an ACL. So throughout this nugget, sometimes we'll hear it as an access control list, sometimes as an ACL. It's the exact same tool. All right, let's take a look at our network here. We have N1, N2, N3, N4, N5, and N6 as computers on this network that under the normal flow of routing through routers A, B, and C would be able to talk to each other. Let's say, though, that we didn't want that to happen. For some reason, we wanted to preempt N1 from talking to N3. We can do that with the tool we referred to earlier as an access list. That access list will always be placed on a router. So you have router A, B, and C, and it can be placed on any interface on any of these routers. Let's now look at what we're going to cover in this nugget. We're going to start off with the IP header because it's so important. It shows us exactly what we can filter on. The access list command is what we're going to use in order to create our access list. ACL ranges. This is important to know because in the access list command there's actually a spot where you will fill in an ACL range so that the computer will know what to expect after that portion of the command. Next, ACL filtering. We'll understand how this happens. ACL processing. We'll understand how a router will go down an access list with many entries and decide when to permit or deny based on the criteria we set. Applying an access list. This is where we study how to apply the access list we built earlier with this access list command onto a router interface like we showed you on the diagram. And then we're going to end up with editing an ACL. ACLs can get lengthy and they may have 10 or 20 lines in it. If we want to omit some of those lines and place another line somewhere in the middle of that access list, we're going to look at how to do that here. All right, let's get started. Let's start with the first bullet, the IP header. Here we go. All right, I know there's a lot of information on this slide. Don't let it intimidate you. Don't get nervous. I'll explain exactly what everything is. First of all, this boxed area here is the IP packet. Note that I didn't say IP header only. From this area here, from the beginning, right here from this version field, over to the point that we end with our options, this is the IP header. This portion here is the data. Now remembering the OSI model, you have the network layer, which is IP in this case, and then you have the transport layer above that, which is either TCP or UDP, and above that we have the application data. So if you were say using a telnet program, the information that you're telnetting across would show up in this data field. So let's start with the header. And let me give you a little bit of an analogy to make this a little bit easier. This IP header from the version field to the end of the options field is analogous to an envelope for a piece of mail you might mail over the U.S. Postal Service. Okay? So you've got an envelope with a source address and a destination address. In the case of a packet or an IP header, we have a couple of other fields that are used to route that packet and to give it certain characteristics as it goes through the network. But essentially, it's the same thing as the envelope. And inside the envelope, we find our data. All right. I have listed on the side here 5 fields that we're going to use for filtering. These are available via access control list for different types of filtering. So let's start with the first one, the source IP address. We find that right here. This is the source IP address. The next one is the destination IP address. Find that right below it. Note that they're both 32-bit addresses. And let's look down here at our diagram. This is our network diagram we started out with in the intro. And now what we're going to do is give examples as to when we would use the source or the destination IP address. So let's say that N1 wants to talk to N3. The source address for N1 is 192.168.12.2 because this is the network number. This is the node or the computer. So let's put that into, if we had a packet, our source address of 192.168.12.2. Now as this packet goes from the computer to the router, if we have an access control list right here on this interface that is keying in on the source IP address, and there's a statement in there that says I want to deny based on the source IP address if it is 192.168.12.2. In this case, it matches, and it would deny that packet. Now remember, any option we put on there, either deny or permit, is what this access list is going to carry out. So now let's switch over to the destination IP address. All right, in this case, let's say that N3 is trying to talk to N1. So just the opposite. And N3 is sending a packet to N1 with the destination address of 192.168.12.2. Now let's move down here to router B. N3 makes the packet and starts to send it out. It gets to this router. We will now put our access list right here on this serial 1 interface. As that packet tries to go out that router, it's going to match it against the access list, and it's going to say, if the destination IP address is 192.168.12.2, let's deny that packet. And that's exactly what we'll do here. All right, so those two are pretty straightforward. Source IP address, destination IP address. The next one is protocol type. Okay, this is a little bit different. What you're going to find here is protocols like, let me list them here, IP, or TCP, or UDP, or ICMP, and the list goes on. And I'm going to show you that list as we go over the command. We'll show you how extensive that list can get. But for now, just understand that there are different protocols that will be identified in this field here by a numeric value, so that when you look at the packet, you know everything that's following has to do with that specific protocol. We can filter on that right here. So, instead of saying that N1 can never talk to N3, now we can say that N1 can talk to N3 unless it's speaking a specific protocol. Maybe to make it easier, unless it's speaking a specific language. So let's say that our access list here said, nobody speaking Spanish can go out this interface. Or you substitute Spanish for ICMP. Nobody speaking ICMP can go out this interface. At that case, if N1 sends a packet, an ICMP packet, out this router destined for N3, it won't make it past this interface. All right, now the next two, source port and destination port, this is where we feel like maybe we're hunting for Easter eggs, because if you look at all these fields, nowhere does it say source port or destination port. So I'm not trying to trick you, but keep in mind the IP headers from here to here, these two fields are actually in the TCP or UDP header, because it's the transport layer. So like we talked about earlier, this IP header is the envelope. Inside the envelope, we have a TCP header and the data. So the first 2 bytes in the TCP or UDP header are the source port number. So let's just essentially say, let's say this portion here is going to be the source port number, because remember, port number is at the transport layer. And then the next 2 bytes in the TCP or UDP header are the destination port number. So the next section is destination. We can use these in the same way we use the source and destination IP address to stop traffic with access list. So if a packet is coming from N1 to N3, it's a TCP packet, and it's using, let's see, for the sake of argument, port 21, so it's FTP. It'll go to this point here, it'll say no FTP is allowed because port 21 for TCP is FTP, and it'll drop it. Same thing if that was the destination port. All right, so, it was a lot of information, but it's pretty straightforward on the things that we can filter on. So let's move on to the next section. You know what? Before we go, let me show you this in the router. All right, I'm going to pull up my router. Let me log in. Get into the privilege mode. And enter into conft, which again is the configure via terminal. Once I'm into the conft, I'm going to type out the command access list 100 permit. I know you're not really familiar with this command as of yet. It's the next section where we're going to cover it in detail. But for now, bear with me. I'm going to show you where we can fill in some of these IP header fields within our access list. So we're going to do that. And I'm going to go with the magic question mark. I love this because it shows you all the options available at this point in the command. All right, here we see it. We had talked about protocols earlier within the protocol field. The ones I had named were IP, TCP, UDP, and ICMP. You can see some others here. In fact, you'll note that some of these are routing protocols like EIGRP versus routed protocols like IP. So, there's a mix of both in here. So excellent. Let's say, for the sake of showing you this command, we're going to opt for TCP and move on and go with the question mark again. Just as we had stated before, it wants a source address. It actually should state source IP address. You can opt for any or a specific host, but this is the source field. So for the purposes, again, of our example, we're going to opt for any and move on to the next field. This is where they want the destination IP address. Same options of any or host. There are some other ones here. I'm not going to ignore these options. It's just if I type any at this place, type in the question mark, we'll see them show up here. And this is where I'll explain them. This is where it gets really cool, because this is the portion where we're going to use the TCP or UDP port numbers that we spoke of out of the transport layer header. So let's see here. We're going to start with EQ. Stands for equals. So match only packets on a given port number, or this exact port number. The syntax of this would be EQ space, let's say 25 for SMTP, because that's the port number. The next that I want to cover is greater than, or in this case, match only packets with a greater port number than 25. So it would match 26 on up. Another is lower than. Again, if we use 25, it would match below 25. A range. This can be 1 to 1024, which is all the well-known ports that are available for TCP and UDP. You may want to block them and allow just return traffic above the well-known ports. Now you see there are some other commands in here that we can issue. Let's look at them for a moment. Log, we're going to log an entry. Log input, we're going to log including the input interface. Precedence. This is a field in the IP header, and if you go back a couple slides, you'll actually see that. What you need to understand, though, is that field is not used. It's 3 bytes within the type of service field. It's the first 3 bits, and it's not used. Next, type of service. Although it is used, there's only 4 options there, and I have never seen it used in a real-world access list. So not as important. Understand that it's available, and if you need it, you can look at those 4 options. Beyond that, we have the established. The established command is used with connection-oriented protocols like TCP. Right now, let's just table that command and say we're going to discuss it later, because in another video we have it to where we understand how a connection-oriented protocol works and how the established command with an access list will help us in that scenario. All right, I think that's it for our access list command. Now we can move on to the next section. Excellent. All right, so far we've covered the IP header. Next we're going to move into the access list command. Let's take a look at that. Here it is. Access dash list. That's going to be standard in every ACL that you enter. That's always going to be the same. The first option comes in, the range. As you can see, I've listed 5 sample ranges here at the top. They affect different protocols. Some can be IP, some can be IPX, and some affect each of those protocols in different fashions, standard versus extended. Here's the numbers. Standard IP, 1 to 99. Extended IP, 100 to 199. Standard IPX, 800 to 899. Extended IPX, 900 to 999. And the SAP IPX is 1000 to 1099. I've listed these 5 not because they're the only choices in the range, but because we are going to cover these specifically later on in this nugget. All right, the next option that you have is permit or deny. The only 2 choices. We're either going to permit based on certain criteria or deny based on certain criteria that will follow this portion of the command. The reason I don't go any further is because this command is going to change dependent on the range or the type of ACL that we're configuring. Let's look into the router so we can see how this is applied. Let me log in first and get into the proper privilege mode. Config T. This is where we would actually type in an access list command. Access dash list, always going to be the same. Let's work the question mark here, and we see our options. As you can see, like in the previous slide, 1 to 99, IP standard. 100 to 199, IP extended. Here we'll see our SAP filter, And down here are two IPX filters, standard and extended. You do see, however, all these other options, and I just wanted you to be aware of them. There's actually 1 to 1299 is the actual range that can be put into this next field, and it has different effects depending on what you want to do. So let's go ahead and jump with 99 into this command, type the question mark, and again you see, as we stated earlier, the only options you have are deny or permit the specific traffic based on a criteria you're going to set forward in this access list. That's it for access lists. Now we get to move into ACL filtering. This is the real power behind ACLs. Let's do it. All right, here we go. ACL filtering. We're going to start off with a reminder of the access list command. We have the access-list, as we always do. We're going to opt for 99 this time, which means, now that we've gone through the ranges, a standard access list. We're going to permit. We're going to key on the IP address of 192.168.1.1. And now we get into our wildcard mask. Now this is the power behind our tool. If we say the access control list is a tool, this is the power of that tool. This is what we use to decide what we're going to filter on within this IP address. All right, an important note here, all 32 bits of an IP address can be filtered. Okay, what we want to know in this wildcard mask is a 0 equals must match, a 1 equals ignore. This is just the opposite of what we found in subnetting. Remember, the opposite was true. When you had a 1, that value was turned on, and when you had a 0, that value was turned off. So just keep in mind that we're doing a little bit of a flip. The other thing to note, wildcard mask is also called an inverse mask, depending on who you're talking to. So if you hear them, they're interchangeable. All right, let's get down to our explanation. We have an IP address, as said earlier, 192.168.1.1 that we're trying to get across the network. Okay, this is our access list command up here. Now we're going to substitute in this position, the wildcard mask, each mask that you see below. Let's start with the first one, 0.0.0.0. As we say up here, anything with zeros must match. So each of these zeros represents a complete octet. Now we studied that in IP addressing. So if you recall, that's actually 8 placeholders. So this is shorthand for 8 zeros between each period. So this is equal to a host. Everything must match exactly. So the only thing that will pass under this command of an IP address 192.168.1.1 with a wildcard mask of 0.0.0.0 is that exact IP match of 192.168.1.1. All right, let's move on to our next mask. We're going to, as you can tell down here, we're going to peel back by octet each time. The next one, 0.0.0.255. Again, recall back to our IP address lessons, a 255 illustrates 8 ones in this octet. So this is our answer. With the zeros, 192.168.1, those first 3 octets must match exactly. And you can see that they do with our IP address. Now this is where it gets interesting, and this is the cool part of our tool. In the 4th octet, we can have any value from 0 to 255, 10, 11, 29, whatever number you can think of between 0 and 255. And that is because here we ignore every one of these bits. All right, I think it's probably starting to sink in, so let's continue. All right, the mask we use now, 0.0.255.255. Apply it to our IP address, and we get 192 and 168 must match exactly. The next 2 octets, represented by 1s, can be any number from 0 to 255 dot any number from 0 to 255. Our next example, if a mask is 0.255.255.255, the one octet that must match exactly is 192. After that, dot 0 through 255 any number, and so on for the next 2 octets. And then finally, if we have a mask of 255.255.255.255, that means, because they are all ones, we ignore every bit that is there, and we permit any IP address between 0 to 255 in every octet. And you can see here, essentially what that means is anybody will match this line. And you use that for a permit, if you want to permit everybody after a couple of lines of deny, or the other way around. After a couple of lines of permit, if you want to deny everybody, you would use this any command. And there is a shorthand in the router to let you do that. And as you see up here, same for the host. Now recall when we were looking at the the access list command a moment ago, you did see these shorthand options available, and we used one in our examples of any. All right, let's drive this home a little bit. Here's an example. First of all, let's start with our command. Access-list 99, standard access list. Permit is going to be our action. Again, permit or deny are the two choices. The IP address that we're going to use as a key is 192.168.17.65. What I've done is I put the binary equivalent here on this line. This 8-digit representation for binary equals the decimal 192. This 8-digit representation equals the equivalent of 168 in decimal. This is 17, and these 8 digits equal 65. Recall from our IP addressing how that works. If you don't, I'll give you a quick example. Remember, these places are 1, 2, 4, 8, 16, 32, 64, and 128. So the two bits that are turned on are 128 and 64. When you add those up, 192. All right. The next important piece, and again, the fire behind our tool, is the mask. Our mask is going to be 0.0.255.255. All zeros in the first octet, all zeros in the second octet, because we see them here. .255, that's all ones here. And the reason for that, just a quick explanation again, the placeholders are 1, 2, 4, 8, 16, 32, 64, 128. Add all those together because they're all turned on, and you get a decimal value of 255. Same thing for the fourth octet. All right, so let's obey our rules that we printed earlier. A 0 must match. So bring everything with a 0 in the mask down. And the same thing here. These are all zeros. Dot. There are no zeros after this, so we don't need to bring anything down. Only the masked zeros do we bring down. So this is our access list command. This is the IP address that we're trying to get across that access list as a source address. Let's look at it. 192.168.1.1. The binary equivalent I've written out. This is 192 as it was up here. This is 168 as it was up here. Now it's a bit different. This is 1 and this represents 1. Now our mask is exactly the same. We're still using the 0.0.255.255, and you see that here. So let's match the zeros. 1, 1, 0, 0, 0, 0, 0, 0. Because all we're doing with these zeros is bringing down exactly what we see in that IP address. 10, 10, 10, 10, 00, dot. These are all ones, so we don't have to worry about it. Once the computer has done this, you ask one question, one simple question. Do we have a match? Is this value right here equivalent to this value? Yes, it is. And because it is, we follow through with whatever action is in this line. That's too cool, isn't it? I mean, that's as simple as it gets. This is the long form of what the computer is doing. You know, I love that when you actually know what's going on behind the scenes. All right, that's pretty straightforward. We're going to try another example now. Our next example is going to be a bit more tricky. All the concepts are exactly the same though, so stick with me. All right, you see our command again. Access -list 99 permit 192.168.17.65. So above, so far with this IP address is exactly what we saw in the last example. And we'll see that here. The 192 binary representation, 168.17.65. This is where it gets different, is our mask. This time it's 0.0.16.64. So let's look at that. 0 is all zeros. Again, the 16, only the 16th digit is active. So again, with our placeholders, 1, 2, 4, 8, 16, it's on. 32, 64, 128. This is a value of 16, and this is a value of 64. So let's obey our rules and bring down everything that is a mask of 0 from the IP address. So 1, 1, 1, 2, 3, 4, 5, 6, 1, 0, 1, 0, 1, 0, 0, 0, dot 0, 0, 0. We're not going to bring this down, and the reason for that, I'm just going to leave it blank, is there's a 1 there. 0, 0, 0, 1. You saw we brought that down from the IP address. Dot 0. This is blank because it's a 1. 0, 0, 0, 0, 0, 1. So let's finish that 0 there. All right, we do the same thing down here. The same IP address we tried to pass earlier, we're trying now. 192.168.1.1. Binary representation 192.168.1.1. The mask, exactly what we saw up here in the mask, we have down here. So let's work this out. For the zeros, again, we bring it down. 1, 1, 2, 3, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0. Ignore this place. 0, 0, 0, 1, dot 0. Ignore this placeholder. 0, 0, 0, 0, 0, 1. All right. Then the computer simply asks itself again, does this number match this number? And they match exactly, and we pass the traffic, because in this case we are allowing a permit. See how crazy that mask is? And it's not as easy as zeros and 255s only. We have these bits in the middle of our octet being ignored. And that's why the key was on the first slide, all 32 bits in an IP address can be turned on or off, ignored, or paid attention to based on this mask. You can get into some wild, wild configurations. Just take care that you don't do that often, because it's an administrative nightmare if you do. So use your access list wisely. In some cases, you might have to do something like this. And if you do, administer that access list on your own, because as soon as somebody else comes in and takes a look at it, there's a great chance that they're going to get confused and make a mistake. All right, let's go on to our next topic. We just got through covering ACL filtering, probably the most important part in this section of the ACL Essentials. Next, we're going to go into ACL processing. All right. The big question here is this. In reading an ACL, there's two choices. Well, with any list that you're ever going to run into in computers, it's either processed by first hit or best fit. Now, in the case of an access list, it's first hit. This is the answer, and we're going to illustrate how that happens and why it's important. Here we go. I have 3 different access lists here, 1, 2, and 3. We're going to pay attention just to the first one for our first example. Here we go. Access-list 99. This time we're going to deny. So understand we're denying a host. Remember our key words and looking at this command and the filtering. If you have a host, it's really the equivalent of writing out 192.168.1.1 as an IP address, and then the mask 0.0.0.0. They save you a little bit of writing by allowing you to put down the keyword host. And it just makes more sense, too, as you're reading these access lists. The next line, access-list 99 permit anybody, which again is a shortcut for 255.255.255.255. Okay, this is our access list. I am trying to run a packet through an access list with the source IP of 192.168.1.1. Let's see what happens. I go to the first line. All access control lists are read sequentially from top to bottom. And remember, we're going to hit first hit. So the first hit says, I want to deny anything with the IP address 192.168.1.1. Is that what I have? It'll run through the example we just ran through, and the computer will say, I have a match. That packet is denied. Excellent. My information is safe. That's what I wanted. I don't even hit the second entry because I've matched on the first. But if I had any other IP address as a source IP coming through, like 192.168.1. Let's say this changed to 2, then it would go to the access list, not match on the first one. It would have to go to the second line where the match is any, so of course I match, and it does exactly what's said within the line, and it'll permit that traffic. So this ACL essentially denies one address, allows everybody else. All right, let's move to our second example. I'm going to use the same source IP that I used here, 192.168.1.1, the original. on this access list, but let's read the access list first. Access-list 99 permit 192.168.1.0. The mask is 0.0.0.255, which means to us I have to match the first three octets. The last octet is any number from 0 to 255. Then my next line in this access list 99 says deny a host. So here it's exactly this line. And the third line is exactly the second. All we've done is add a line in the beginning. Now let's process that same packet coming through. Our goal is to deny any packet with this source IP address. Let's see if it happens. We hit the first entry. This is a permit statement. The mask says 192.168.1 dot any number in the fourth octet. Does it match? Yeah, it does. 192.168.1.1 matches. I'm going to permit. I'll never get to the deny statement, and because of the order of these entries, I'm not accomplishing what I want to accomplish with this access control list. Pretty straightforward, right? We just want to illustrate first hit versus best fit. It doesn't run through this list and say, you know what? Here's this exact IP address here, so it must want to deny this. It doesn't do that. First hit. Let's go to our third example. If we had one line, access list 99, deny, host 192.168.1.1, which is the first line you see here, and that's it, let's see what would happen. Some of the logic behind doing this might be, okay, if I want to deny this address and let everybody else go through, why can't I do that in one line? And the answer is simple, but it's kind of hidden. There's an implied deny any at the end of every ACL. So if you write these with, in fact, we'll start with this one, an implied deny any as the last line. Let's process this. Anything coming in with a source IP as 192.168.1.1 will be denied by the first statement. That packet that we passed earlier, 192.168.1.2, when we had a 2 here, will be denied as well. We won't permit any traffic at all. So it's important to remember that. So if we go back to our first example, this is the correct way to deny one IP address and deny everybody else, or permit everybody else, because this has an implied deny any that you just won't see at the end of the access list. All right, very important. Keep that in mind. So that's how you read an access list. First hit. Let's move on. Applying an ACL to an interface. This is our next subject. All right, the first thing we're going to have to do is understand what command is used to apply an ACL to an interface. And we find it here. The command is IP access -group, then a number, which is the number that we assigned in our access list. So the examples we worked on the previous whiteboard were 99. We could type in 99 here, and we're applying all those access list statements to this access group applied to an interface. And then we have a choice of whether that's applied in or out. So let's look at why that would be important. Let's pretend this box is our router. Our routing logic sits here in the center. Each interface, E1 and E0 in the case of this example, E standing for Ethernet 1 and Ethernet 0, have an option of traffic coming in or going out, and the same thing here, coming in or going out. We need to tell our access list which way it needs to be applied with the access group command, either coming in or going out. And that's the purpose of this statement. Understand that the default direction, if I didn't include either one of these words, if I just stopped at the number 99 and hit enter, the default for the direction is outbound. So here's the default here, and here's the default here. Let's move into the router and take a look at this actual command and how it's applied. Here we go. Actually, before we move on, we're going to move into the router, but one thing I did forget to mention is this IP access group command is a subcommand. Now, if you recall from our conversation that we had when we ran over iOS basics, two types of commands. One is a global command. This affects the whole router, the entire router, and then subcommands that are beneath global commands. That's what this is. And the reason for that is, look at what we're doing, applying an ACL to an interface. So the first thing we have to do is use a global command to define an interface. So if we were in config T, I would type something like interface E for Ethernet 0. Now I'm in this interface here, and I can assign my ACL to that interface. Now we can move on to the router. Let me log in. First thing I'm going to do is a show IP interface brief. This is a command that's going to show you all the interfaces on your router. Very key command, and I would remember this and use it in your daily work. What we see on this specific router is we have Ethernet 0 as an interface, Serial 0, and Serial 1. Ethernet has an IP address assigned, and it's up and up. So everything's ready to go on that. Now let's type in a command that's going to show us our access list. This will show every access list on the box. We have one, access list 99. Okay? These are the lines here within access list 99 that is a standard IP access list. I know this looks kind of weird. I mean, this isn't the format that we put this in, right? So why does it show up there? Let me show you something. If we do a show configuration, what we're going to see is our access list here in the format that we originally put it in. So it does save it that way in the configuration file, but when you do a show access list command, just remember it comes out a little bit differently. Let's move into config T and make our changes. The first thing we're going to do is use the interface that we saw, interface E0. Now we are in a config interface subcommand. This is where we apply IP access group 99. Now, we're going to go to the magic question mark, and this is to illustrate what we had mentioned before. You can go in, you can assign it out, or you can simply hit return, and it's going to default to out. Right? So let's do that. It's an out. Once we've done that, let's get out of config T with a control Z, write this to mem, which is saving from our regular RAM to NVRAM. Once this is completed, we're going to do a show config again and see that on our interface this is assigned now. All right, let's look at E1, or I'm sorry, E0. IP address, that was already there. Now check this out. IP access-group 99 is out. So it shows you the default out. And everything in that access group is now applied to this interface. And here's the access list. Isn't that just cool? That's as easy as it gets for a very, very, very powerful tool. All right, let's move on to the next section. The next section is actually our last section in this nugget. So we're going to stay right here in the router. And I'm going to ask you, do you see anything odd in this access list? Take a look at it for a moment. What it is access list 99 deny, and then this subnet at the end isn't really needed because if you remember, there's an implied deny any. So everything would be denied. So it's not needed. But through the course of this material, you can't see the implied deny all. So I included this just to make points earlier in this nugget. But now, in a real-world situation, what we would normally see following this deny line is a permit any. And because we're going to talk about editing ACLs, it's perfect timing. Let's do that. Let me get myself to a configuration prompt. And what we're going to do is add to access list 99 a permit statement of any. And let's see what it does. All right, Control Z. And let's show the run. This is our running config. And what we're going to see is it did add the line. Here's the access list. And it added it to the end of the access list, which is great in our case. But let's say we wanted to add another line. We made this access list and we said, you know what? I actually want to deny another part of a packet. So we want to include another deny line here. Let's try to do that. Okay, access dash list. This time it's going, or it's still 99, but this time it will be a deny statement. And let's deny, let's see, just the whole 192 range, 192.0.0.0. There we go. Let's see what happens with this. Let's Control Z out of this, show our running config. All right, very interesting. Look what we have now in our access list. Remember we talked about access lists operate on a first hit basis. this deny statement was appended to the end of the access list. Because the permit any statement is before it, it has no effect. So when we're editing ACLs, if you want to add a line and you need to add it at the end of the ACL, there is no problem there. If you need that line added anywhere within the ACL, you can't do it. And in that case, you're going to have to rebuild the ACL. But let me show you something else. Let's say, okay, we looked at this access list and that last line just didn't fit where it's supposed to. I want to get that line out. Let's try that. Again, into the configuration mode. No. And this time I'm just going to highlight this line, copy and paste it, and hit enter. It took that entry, right? So what we would suspect we would see is probably an access list like this, without the last line. Let's see if that holds true. And it doesn't. Do you see that our access list is gone? It's nowhere in the config. In fact, if we use the more pointed command, show access list, it says, I don't know what you're talking about. So anytime that we delete a line, it takes the whole access list out. Wow, it's pretty interesting, huh? We can't add a line to the middle, and if we delete a line, it completely blows the access list out of the water. We still need to complete the editing of our access list, though. So what we're going to have to do now that we don't have one is going back into CompT and build our access list again. So let's do that. Access list 99 permit, again, our first line was 171.16.32.5. We're allowing that. And I'm going to go through a little bit of shorthand as we do this. With the up arrow, as you recall in our iOS basics, I can bring myself back to the prompt that I need to be at to build these a bit faster. 192.168.1.0, oops, .0. All right, mask of 0.0.0.255. Enter that, bring it up. .128 was the network here, and the mask was actually 127. See, these editing functions are actually really useful with the arrow keys, so definitely I suggest that you use these if at all possible. Now, we got to take care here that we're getting into a deny statement. If you recall our original access list, 192.168.0.0. All right, now this is the new line that we were trying to add earlier. Again, we couldn't do it. We couldn't slip it in the middle, and we could not edit it any other way either. So I'm going to take the whole network, denied, adjust our mask accordingly, hit enter. Now we have our new line, and then the last line is going to be our permit any that we added earlier. Now we have it. All right. Let's show this. This was our end goal, this access list. And you see that it actually is quite a process to get here. You have to blow the access list away and completely rebuild it. Now there's a question though. What happens while we're rebuilding that access list? Traffic, is it passing? Is it not passing? And I tell you, the answer is a bit interesting. Right now, with the iOS features, when you delete the access list, the access group, the only thing it has left is the implied deny any. And so it stops all traffic. So our options are to leave that on there and no traffic gets in, depending on the criticality of the computers behind us, or to take the IP access group command, and let me show you that command so you remember what we're talking about. It's on the interface, and it's right here, interface E0, IP access group out. If I leave this command on here, traffic is stopped. If I take this out, all traffic is allowed. And depending again on the security of your computers on the back end, that might not be a good idea. Completely your call. All right? So let's talk about real-world applications for a minute, though. If you have access lists, they're more than likely going to be complex. And with any complex access list, when you go to edit it, there will be typos, and there will be times that you put the order of the lines in the wrong order. And when you do that, you're going to have to blow the access list away again and then edit a new access list. If there's another typo, after you look at it, blow it away and do it again. You can imagine the time that we're vulnerable for our networks. What's a way around this? I'm going to show you. All right, let's stop this. Let's bring up our access list again, because I'm going to show you something about it. It needs to be adjusted. All right, we have just added the line access list 99 deny 192 in that entire network, right? So what use does this line, access list 99 deny 192 168, really have? It's simply an additional line in our access list that can serve to confuse us or take up more process time. So we want that out. This time we're going to use a different process for doing this. We're going to copy this information, bring up Notepad, paste the information in the Notepad, and we're going to perform our editing here. Note that while we're editing, there is no effect on our computers in our network. So let me take this line that we feel doesn't need to be here, simply back it up, then I'll select all, because this is now the access list that I want. Copy here. Let's go back to our router. Let's go into conft. Now take care, if we were simply to paste the lines that we had earlier into this config, we would not have the effect of deleting this line, because again, it appends it to the end, or what you would see here, something a bit new, is if it is exactly the same line that is already in the ACL, it'll just leave it there. So we wouldn't have this gone. So what we have to do is blow away the access list, as we did before. So we just say no, access list 99. And now we can build it back up. This is where I'm going to use the paste command. Much easier. See, every line that we had, hit an enter at the end line here, is applied. Let's Control Z, and let's show our access list and see if we had the desired effect. All right, there it is. Here's our access list. The deny line is gone that we wanted to delete, and it was much easier. And if we had had some rework time or some time with typos while we're in Notepad, it would not have affected traffic on our network. Isn't that awesome? Man, what a session. We covered quite a bit. In fact, let's take a look at exactly what was covered. We looked at the IP header, its true structure, and what we can filter on. The syntax of the access list command and when to use it. ACL ranges, protocols affected, and the features. ACL filtering, this is the true power behind our tool. ACL processing, first hit, easy enough. Applying and editing an ACL, real-world type solutions. Love it. I hope this has been informative for you, and I'd like to thank you for viewing.